11, ladies and gentlemen. Thank you, sir. All right. Ladies and gentlemen, from a token that's really having its day right now, from the Phantom Foundation, please welcome Michael Kong.
Yeah. All right. Sorry, go back here. All right, first of all, thanks everyone for being here. It's great to see everyone here together. I know COVID was a bit of an issue in terms of getting crowds and communities together, but it's really great to see everybody here for the conference. And I, really thank Mo and Harry and the organizers for organizing this conference for the rest of the for an entire week, actually. And I hope you guys have a great time. So I'm Michael. I'm the CEO of Phantom. Phantom is one of these like layer one blockchain smart contract platforms, so you can build applications on top of them. And what we like to say about Phantom is that it's like fast, secure, permissionless, leaderless. So it's just this open source technology where anybody can build applications on top of it, where anybody can join and leave the network when they want, and they can build all sorts of applications on Phantom. And we've seen a whole bunch of different applications being built on Phantom. And so it's one of these like newer smart contract technologies based on some very different consensus technology from what you see on, say, like Ethereum. So first of all, there are some key features about Phantom that kind of make it like a unique and a very like fast and good blockchain to use. First of all, like transactions are confirmed in after one block. So essentially, as soon as the transaction gets entered into the network, it gets passed around to get 2/3 plus 1 of the total validating power of the network. And then as soon as it's included into a block, which is included into the chain, then it's final. So the transaction is confirmed after a single block, so there's no waiting for blocks afterwards. There's no longest chain rule, or what's known as a probabilistic fault tolerance. So this is very different from like Bitcoin and Ethereum, and this is a key feature of Phantom, is that it processes transactions in an asynchronous manner as opposed to a synchronous manner. So what that means is that as soon as a transaction is sent from a user to a validator, it automatically gets propagated amongst the nodes that confirm transactions. Whereas in, say, Bitcoin and Ethereum, you have to wait for a block to be mined, and transactions get processed in a very sequential manner. So that's kind of the key feature of Phantom's technology. It allows you to get like faster, cheaper, and like better user experience transactions than, say, some like other chains that are out there. And of course, it's EVM compatible. So what we mean by EVM compatible is that you can run all sorts of different smart contracts on the platform. So the way that you write, compile, and deploy smart contracts on Ethereum works pretty much the same way as on Phantom. So this is a very important feature of Phantom in that developers who are very used to building on Ethereum and writing smart contracts in, say, Solidity or Viper will be able to translate that technology onto Phantom and basically take advantage of new and improved consensus engine. So, as you've seen here with Phantom, the Phantom ecosystem has really grown quite large from where it once started. When we were developing the core consensus technology, there wasn't really much on it because it wasn't built. And then in 2020, we started to get a few more applications. Just to name a few, like big ones on Phantom, we have like Spirit Swap and Spooky Swap, which are these like DEXs or decentralized exchanges that we see that were forks of like Uniswap and SushiSwap, and with a great interface. And there are further like projects on Phantom as well, like KeyDAO and Scream, which is a lending and borrowing protocol, and also like a whole bunch of like NFT and other kind of projects on there as well. So the ecosystem is really growing quite large. So I wanted to talk about smart contracts and some of the challenges of smart contracts and how we're trying to address them, because there's still a lot of scalability issues with blockchain technologies that really are the reason why it doesn't have $1 billion, it doesn't have like 1 billion users using it. It has to do with scalability that comes down to the consensus and also the middleware layer, which is essentially how smart contracts are processed. So what are smart contracts? Well, they're essentially just computer programs. And they're computer programs that run on top of a distributed ledger. And in order for a smart contract to run under the hood, you need something called a virtual machine. And it's basically just a layer of software that can interpret a smart contract and write that information to the chain underlying. So you need this like virtual machine, and all sorts of software runs virtual machine. Like your phones run virtual machine, Android is a virtual machine, etc. It's all translating the applications that are written in different languages to another language that a computer can understand. So there's multiple ways of achieving scalability, and I kind of like to break it down into two categories. One, improving like the underlying consensus, or essentially the way that transactions get confirmed. So like with Phantom, for example, we've developed an asynchronous network where transactions get processed as soon as they enter into the network. And this is quite challenging to do because all properties of ledgers need to have the property that transactions are that all ledgers are entirely consistent across all of the nodes, that every transaction is ordered in exactly the same way across all nodes. And so what we spend a lot of time at Phantom doing over the years is really figuring out how do you get that final ordering of transactions. And that's led to quite a big improvement. There's other ideas like sharding that we're looking at exploring, and of course Ethereum and other chains are looking at exploring as well, which I think theoretically can add to a lot of scalability for the network. And there are other alternatives as well, such as what we call like layer 2 solutions. So building up these sorts of roll-ups like you've seen on Ethereum with like Optimism, Arbitrum, and others that try to do computation on a separate layer or on top of the Ethereum and not do as much computation on the underlying chain because there's only a limited amount of processing that, say, Ethereum or the underlying network can do. And of course, there's a whole idea of side chains as well, which is basically like running a different blockchain that's connected to your main blockchain that's kind of existed for the past few years. But one thing that's really not talked about a lot is also improving the scalability of the middleware, because the EVM has a number of limitations, and one of them has to do with scalability, which is being able to perform like reads and writes very effectively compared to how it is now. So with the EVM, we kind of noticed in some research that we've been doing with the University of Sydney and Yonsei University Programming Languages team to do with the performance of the online virtual machine, that reading and writing data from chain, so retrieving data from chain and kind of manipulating the smart contract and then running back on chain gets progressively slower. And that's because of the kind of underlying data structures. It's called the Merkle-Patricia trie, but essentially, like as the chain grows, reads and writes get progressively slower, and we've seen that in degradation performance for Ethereum, and we're starting to see that on Phantom and other chains that are EVM-based as well. And there are a number of chains that are EVM-based. Phantom is just one of them, but every single chain that uses the EVM experiences the same sort of scalability problems. And that's because the scalability problems are not just with the consensus, but also to the virtual machine itself. And so what we want to do is be able to have reads and writes that are a lot faster than they currently are, because right now the technology is not very scalable. You've also got the case that every single smart contract has to be repeatedly executed across all validator nodes, because that's how you achieve consensus in the end. So if there's an alternative where you don't need all validators executing every single transaction, then that kind of would be ideal. That being said, though, the EVM really does work. Even though the design is like relatively simple in terms of virtual machines, it is something that is really, really effective, because we've seen the tremendous growth on Ethereum, we've seen tremendous growth on Phantom and other chains. So the EVM really does work in the end, but there are a lot of improvements that I think we can make to it. And when I talk about like technology improvements, whether it's to do with consensus, middleware, or application layer, whatever it might be, what really matters in the end is about user experience. Because in the end, the blockchains are there not to build technology for the sake of building new technology, but building technology for the sake of improving the user experience. So when it comes to user experience, I like to say there's really three things that users care about. It's really just these three things fundamentally. One of them is how fast will it take for my transaction to be confirmed, how much will my transaction cost, and is my transaction going to be secure? So obviously, the chain needs to be secure, otherwise people aren't going to have confidence using it. People always want the thing that's the most cost effective, and they always want to make sure that the transactions are confirmed as quickly as possible, because when you're going to a store and you're making a payment, you don't want your transaction to take a long time. You want it to be done within like a few seconds. And so performance improvements are all about user experience and being able to scale that up to a lot of users. And that's what's really important that I think a lot of people sometimes don't really talk about when they're talking about the technology. That this is what we're trying to achieve. So right now with Phantom, we've reached a stage where it's pretty usable. We have an asynchronous network. It confirms transactions. It's consistent across all the ledgers. And because the technology uses asynchronous programming to confirm transactions, we've seen tremendous improvements compared to, say, Ethereum. So transaction fees are a lot lower than Ethereum for the same sort of transaction. For example, this is just a simple account-to-account transfer on MetaMask that I think you guys will be familiar with. And as you can see, that the fee is like a fraction of it, like maybe like 1/100th or 1/50th of it. And there's actually a really nice website that I like to point out where you can put in your MetaMask address that you use both on Phantom and on Ethereum. And you can see kind of like how much gas you spend on Phantom and how much it would cost on Ethereum. And the difference is very, very big. And this is a big reason why I think layer ones like Phantom have got a lot of traction, as well as like other layer ones as well, because a lot of people can see that Ethereum is not very scalable. They can't afford to pay the transaction fees, which are very, very high, even sometimes in the few hundreds of dollars, if not $1,000 for some transactions, depending on network usage. And so so people use alternative chains in order to confirm their transactions faster and also pay a lot less for the fees for the sort of actions that they want to perform. So we've got a few current developments that we're working on. One of them has to do with improving the performance of read-writes for the virtual machine, like I talked about before. And this has to do with replacing the underlying data structure of how reads and writes are done by using what's known as a flat storage, which is basically a way of like being able to really access data very, very fast and also write it into the chain very, very fast as well. There's a number of challenges related to that. But it is a solution that we've kind of like figured out and tested empirically, at least on Ethereum, using parity and Geth to see if it would work. And so I think the same sort of logic should work on Phantom because it uses the same Ethereum virtual machine. We're also in the process of designing or testing out a few different new virtual machines as well. And these new virtual machines would have like improved performance because of the underlying structure, and also allow you to compress the code a lot more than is currently compressed, hopefully to the factor of like, say, 5 times. So this is also important in terms of minimizing the size of the chain, which is also like another issue in terms of scalability, especially when you're running a lot of validators. And we also want to have continued improvements to the underlying consensus. So being able to pack more transactions into blocks, for example, making that more efficient, exploring concepts such as sharding and others as well. There are a number of challenges to this, though. One is that you have to have a new way of verifying information that's stored in this flat storage structure. So if you don't have this sort of like cryptographic proof, then basically any validator can insert any like random information that they want into it that doesn't necessarily reflect how a smart contract has actually been executed. And so there's a lot of technical challenges around it and figuring out like the best way to integrate a cryptographic solution for safely storing that information in a flat storage kind of data structure. The other big issue is backward compatibility as well. So if we were to move from changing the client, so changing, for example, the way like data is like read and wrote, or changing the underlying virtual machine, you have to find a point in the Phantom chain because it's live when you're going to do that switch over. And so designing a successful backward compatibility where all transactions and smart contracts are kind of executed in a different manner up to a certain point, and then it switches over to the new technology is something that needs to be really thought of, because a lot of things can go wrong in terms of backward compatibility. So that in itself is also a really big challenge. And of course, a lot of this is still experimental because it's kind of like cutting edge research on the consensus side and on the middleware side. And so a lot of it has to be like empirically tested. A lot of it has to be like theorized as well. So far, the empirical results have been pretty good in terms of getting performance improvements of, perhaps even like 5 times how long it takes for smart contracts to be executed right now. But a lot of that is still like experimental driven. So how it actually works in practice with actual users on a live chain such as Phantom is still something that really needs to be thought of, and we kind of need to see how it goes. So thank you very much for listening to my presentation, guys, and please check out phantom.foundation. Thank you.
Michael, all right. Thank you very much. Couple of housekeeping things, guys.